Alright, today working on a 1988 45 horsepower Mariner. Having some starting issues, so I've narrowed it down to be an ignition issue, and I wanted to walk through what seems to be a pretty common with these classic 50 motors. Actually the stator going bad is what's going on with mine, but I wanted to walk through the removal and installation of that, but also kind of how I diagnosed that it was the stator. So I actually got kind of this guide, so there's a guide here. You may want to pause on this that actually walks you through what resistance reading you have. So for example, this is on the power pack. It says check purple to white, make sure the resistance is 800 to 1400. So you'd go to your power pack here and you'd look at the purple and the white, and so you'd take your multimeter and check between those two and make sure your resistance is between 800 and 1400. Then it has a DVA reading, so for that, I mean, you'll have your multimeter, but you need a special DVA reader. There's a guide on YouTube of how he shows you how to build one of these if you don't want to buy one. But it's just an attachment where you attach that to your voltmeter and then read the voltage that goes through there, and the guide shows that it should be about 4 volts. So when I initially did this test, my brown to black was a little bit less than 4 volts, so I thought my power pack was bad, so I replaced that, but it ended up not doing anything. And so I did some more research and found a guide on the stator. But I want to point out here before I switch to that guide, this actually tells you how to check if your trigger is bad too. So if you read that bottom paragraph there, basically what happens is if your DVA voltages are low, you can disconnect the trigger wires, and if the DVA reading goes back up, then you know your power pack's bad. And so again, that's what happened to me, but the voltage was just a little bit below 3 volt or below 4 volts, and so I thought it was the power pack, and it very well could have been. Maybe the stator killed my power pack, but so I replaced the power pack. I just replaced this unit, and it really didn't do anything. So that moved me to keep looking and trying to figure out what was going on, and so then I found this guide on the iBoats forum that talked about how to check your stator. So these are ohm readings from the stator wire. So for example, the blue to blue white. So these are your stator wires here. There's blue white and there's blue, and you can check between those. And what I found that was between blue and blue white, I had no connectivity or infinite resistance instead of 14 like the chart shows. So that leads me to believe my stator is bad. So I got a new stator coming. But I want to show you kind of how I disassembled that and at least give people some knowledge about what's going on with the ignition systems on here and what to check. I talked to a boats part guy, and he says it happens a lot from what he hears with customers coming to him before they I don't even ask them, they go and replace the power pack, and he says it really never solves the problem. Typically it's the stator, and the stator up in here, that goes bad, and then that ends up killing the power pack after some time. And maybe even the trigger assembly. So yeah, the stator on eBay is about 120 bucks. First thing you have to do is you got to remove the flywheel. So if you have a flywheel holder, do that with a wrench, or I'm going to just use an impact wrench to take it off there. Okay, once you get the flywheel nut off, you can go ahead and take that off. Next thing you'll need to do is get the puller set up. So it's a special puller you have to have. It basically has this crank protector that you'll set on top here, and then you'll thread in the actual puller itself, and then thread in the bolt into there to pull the flywheel up and off. The part number on that flywheel, I have the manual here, so the flywheel puller, there's the part number for that if you need to know that. Okay, that gets our flywheel off. Notice there's a washer in there you don't want to lose, and then it exposes our stator right here. So the next thing, we'll be taking these 1, 2, 3, 4 screws off to be able to pull the stator off, and then you got to obviously remove the electrical plugs too. Alright, now the stator assembly is off. There's a retaining or wire retainer here that you got to take off, and then disconnect the four leads. And you should be all set. You can see that here's the trigger assembly. If you needed to replace that, that's how you get to it, is doing all that. While you got the cover off, make sure to clean everything up. You know, like there's some extra Loctite residue on these bolts that you want to get off and stuff like that. Once you get the new part, you can just swap it. Alright, I need to point out there's two more leads. You can see the two yellow leads there. They run down and over to the rectifier here. So there's just two terminals that you got to take off on the rectifier to be able to completely get it out. The rectifier, just FYI, I mean basically all it does is it turns the AC signal from here and converts it to DC to then charge your battery. So, but there's stator, it's out. I mean it's electronics, so it doesn't visually look damaged. Maybe, I don't know if I'm going to pull off these rubber coverings and see if I can see what's damaged or not, but there it is. Just swap in the new one. Let's say you want to do just a quick double check that the stator's bad. So per the instructions that I found on the iBoat website, number one there's blue white should have a range of 14 to 10 on the ohm readings. And so here I have my digital multimeter. Got one on the blue white, one on the blue, and if I look there I'm getting no ohm reading. So I'm going to show you what that looks like on the red one where I'm getting some. Okay, so we're looking at the red here, so it's expecting a range of about 140. So if I got just my red leads connected, red to red white, and I'm reading about 145. So out of spec kind of, but still close. So you know, that leads me to believe that the stator connection on the blues is bad. Now, if you know the answer to this, please comment because I'm curious. But as far as I understand, these stators have two stages. They have a low RPM stage and a high RPM stage. Effectively, the low RPM is creating energy at all RPMs. But when you get to a higher RPM, you need more power. And so at a higher RPM, the higher RPM stator part kicks in to give the engine more power, or more spark power at that time. So since my motor's been running like crap, it won't start, and it's been running like crap at low RPM. I figure that the low RPM part of the stator went bad, and so I'm assuming that means that the blue-white part of the stator is the low RPM and the red is the high RPM. And so I think, yeah, effectively that low RPM part of the stator went bad on my stator. That's at least my theory here. So I'll get the new stator here in a couple days, and I'll show what that looks like installed, and hopefully show you the motor running. There's again the checks in case you need them. Alright, got the new stator in, so there's the part number if you needed that. I mean with the A's you can do from A21 to 26, I mean they're all basically the same stator. But you got it in there, so there's the four hex, or the four Allen screws that have to go in. Those have to be torqued to 30 inch-pounds. So 30 inch-pounds, quite small. Be careful there not to over tighten and strip those. There's the four there. Then you basically got to take and route the cables around. So you got one cable that comes down to these four leads here. So you have, top one is the red-white, then the blue-white, and the green-yellow, or the black-yellow, which should still be installed. Then you got solid blue, and then solid red, so you got to connect those. You also got to connect your rectifier wire. So I ran that down and then kind of ran it back around the starter motor, and then up through here you can see. So I run those to the rectifier here. So you want to attach those. Use a little dielectric grease. Make sure they're good connection there. The cable mounting. I mean, really with the cable mounting here, you just want to make sure that the wires are far away from the starter. I mean, a finger's width or more, to make sure that they'll never rub against the starter as it's trying to start. Remember, this little part of the starter is going to spin up too, so you want to make sure that there's room in there. Once that's all looking good, you can get your flywheel on. Note that there's a slot on the flywheel, so you want to make sure that slot is lined up with the crank, and then that slides on. Then you got to put the nut on and torque that down to 65 foot-pounds. So use your torque wrench and hold on to the flywheel, ideally with some kind of strap on here. In a pinch, you could try and just stick a screwdriver in here, but I think everyone will agree that that's not the best option. Really just holding with some kind of strap wrench, and then torque wrench there. And that should be everything. Once you do that, you should be ready to start it and test it out. Well, there you have it. It was the Stator. Got it running great now. I want to just give a little bit of an explanation here of what's going on and how this system is working. I'm not claiming to be an expert on this, but this may help someone. So your crank's spinning here, and on your flywheel are magnets. And inside of here are coils of wire. And as those magnets pass these coils of wire, it creates an AC current. And so that AC current is led down the wires to the power box. So effectively, this is like, kind of an alternator. It's creating energy and it's bringing the energy to the power pack. Now the trigger sends leads to the power pack too, and basically the power pack is going to be storing the energy until the trigger says release. When the trigger says release, it runs down these leads to effectively an amplifier, which it amplifies the voltage out to then lead to the spark plugs. You need the amplifier because you need an extremely high voltage to be able to jump the spark gap. So effectively you have the stator creating the energy, the power pack storing, and then releasing when the trigger says to release. That leads to the amplifier, which then amplifies the voltage so that you can create spark.